Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ahmed Hegazy, and today, inshallah, we will make this vertical vessel by using SEG software. As you can see on this vessel, on the bottom head, you have a segmental pieces on the bottom head, and each course of the shell courses include 3 welding lines. And if we take a look to the top view, we can calculate the number of segments on the top head, and from here we can get the orientation of the longitudinal welding lines. Here on the support skirt, you can figure that in this skirt we have 3 cans. Here that's the first can length and thickness and material, and for the second can and third can information. Now let's start creating the main vessel items by using SEG software. And in this part, inshallah, we will create the main in this part of tutorial, we will create the main elements of the equipment, like the bottom head, all cans, and the top head and the support skirt. On the other parts of the tutorial, we will discuss the other parts like nozzles and the top davit. After that, we will discuss the internal components like the support beams and some of the external components like the platform clips. Okay, now let's start our project from new. We will create a new project, and from here let's add the vessel name and select the project location, select it and add the desktop, and from here let's select the vertical pressure vessel and select finish. Here by selecting finish, SEG will start creating the project information or the project folder on the defined location. Here we have the vessel name, and now let's edit the equipment setting. Here, as you can see, the position automatically become vertical and start the simply direction from bottom to top. You can define the service, you can change the vessel name from the tag, you can add a serial number. Now let's define the blade length to be 6 meters and the blade width as 1.5 meters here. So from here the available blade dimensions will be automatically used on SEG. We can change this value to 5 meters, okay, because if we take a look to the bill of material here, the maximum blade length defined it as 5 meters by 1.5, so we could change it to 5 meters by 1.5. And now let's click save. Now let's add the first element. If we take a look again here to this bottom head, we can figure that it's an ellipsoidal head per 1 with minimum thickness after forming 22 and nominal thickness 25, and here the straight flange is 15 millimeters. So from here let's add the first head, which is bottom head. Okay, and from here let's select the ellipsoidal head with crown and the neck radius, and from here let's define the inside diameter. It's 3,900. So if we take a look here for that value, we can get the inside diameter for the vessel. So here we define the inside diameter, and here for the thickness, it is the nominal thickness is 25, straight flange is 50, and minimum thickness after forming is 22. And the material of this one, if we take a look here, it's SA, so we can take that value as a copy and paste it here directly, or you can make a search on it like 24 240, so you will get the grades from here, so you can select the grade from here directly from the list, or you can type it from here. This head not a one-piece head, it's include the segments. If you select the second type, you can figure that it's include a single welding line, but when you select more than 2 pieces, you can figure that you can add some segments to the head. Now let's take a look to the top view to calculate the required number of segments. Here we have first, second, third, fourth, fifth. Now we have 9 segments in this head. So from here, let's add the number of segments as a 9, and from here, let's measure the cut length. So let's get the diameter tool, and here the 1450. So let's define that at 1450, and let's define the gap as 0, and the first longitudinal welding line orientation, it's on 0 degree. So we will keep those values like that and click on save. Now when you click on start assembly, automatically SEG will start creating the assembly of the equipment and creating the head assembly as a head from segments. As you can see here, everything run on behind. Nothing appear on the window, but after creating the head assembly, it will be assembled to the final assembly of the vessel. So if you would like to make a rendering for the element during creation, we will make an option give us this ability. Okay, as you can see here, the direction of the head is not on the correct direction, so we need to flip the direction of the head. So from here we need to select the flip direction. That's the first point, and on the second point, as we discussed, we will need to make a rendering for the elements as a parent or a child during creation. So from here, let's select those options, and from start assembly, let's rebuild the head again to adjust the direction of the segments, okay, to make this head with a flipped direction. Okay, now here this head will be assembled, and now we have this head. If we take a look from the top view, okay, like that, as you can see, the first longitudinal welding line orientation at 0 degree, it will be like that. Now let's add another element, which is the first can. So from here, if we take a look again to the first can, which is that one, it's 1250. Okay, and here we have 3 welding lines, LS101 and LS102 and LS103. Okay, so here let's check the orientation for LS1.1. So let's check the orientation on the top view. It's in at 85 degrees. Okay, and for the second one, it's at 231, and for the last one, which is LS 103, it's on 17. So now let's select the suitable item for that. From elements, let's select the vessel node. After that, select the can, and let's add shell 1. Okay, and from shell 1, let's select from this list, let's select shell from different pieces, which is that item. That item will give us the ability to define the required number of shell blades inside this can. Okay, and we have the ability to control the length of each one. Now let's define the inside diameter of the can. It's 3,900, and from here the height is 1,250, and the thickness is 22 millimeters. Okay, and for the gap we could keep it as it is, and for the material we can copy the material directly from here like that, and paste it here. And the number of segments, we have 3 welding lines. So if we change this value to 5 meters and click update, as you can see here, the SEG calculate directly the length of the last one, because we defined the blade length on the setting of the delivered blade dimension option. So from here, as you can see, the length of this first blade become 5,000 millimeters. And now let's define the longitudinal welding line orientation of the first can. It's at 85 degrees. And now when you click on update, as you can see, the longitudinal welding line orientation when the length of the first can is 5 meters length. As you can see, it's 231. So let's take a look here to this one. So the first longitudinal building line is on or at 85 degrees, and the second longitudinal building line, which L is 103, it's at 231. Okay, so that's the second one. So that's the accurate value for the longitudinal welding line orientation. Automatically, when you add the second the length of the second shell plate, the longitudinal welding line orientation for the last can, which is 17 degrees, calculated automatically. Now, as you can see, SEG calculates the actual values for the longitudinal welding line orientation based on the length of each shell plate length and the first longitudinal welding line orientation. Now let's click Save, and from the Assembly tab, let's click on Start Assembly to start creating the first can. Here, as you can see, we can make a rendering for that element during creation, and here each plate will be assembled manually and will be assembled after that with the final assembly of the vessel. Now let's open this can to check the length of each plate. Now for the first part, let's open it like that, and from Get Sheet Metal Development or Get Flat Pattern, now you will be able to measure the length. Here, as you can see, the length of this plate is 5 meters, as we defined on the form. Let's open the second part and check the length of that part. We get the flat pattern, and from the Inspect tab, if you measure that one of this tool, it's 5 meters. So here SEG automatically calculate the third plate arc length based on the inside diameter of the vessel and the thickness of the vessel and the previous parts arc lengths. Here we have the actual length for the first or the last part of this can. Okay, now as you can see, here we have the first can with the longitudinal welding line orientation. Let's add the second can. So from here, from elements, let's add shell 2. And let's make it looks like shell 1 and click on add. Now we have the second shell, and from here let's define the length of the second shell. So let's take a look to the length. It's 1.5 meters. So let's change the value from here, and let's change the first longitudinal welding line orientation for the second can. It's 198. And from here, let's click on Update and Save. And let's add the third can, shell 3, and let's make it looks like shell 2. Okay. And from here, let's change the length and the longitudinal welding line orientation. So from here, the first longitudinal welding line orientation on 93, and click on Save, and the same length with the same thickness. And now let's add the fourth shell 4, and let's make it looks like shell 2, and click on Save. And now when we select it, we need to define the longitudinal welding line orientation for the first can, and click on Update. Now that value is right, and here now it's okay. Let's add another can, which is can shell 5, and shell 5 will be typical to, let's make it looks like shell 3, and from here we will keep those dimensions as they are. And for the first longitudinal welding line orientation, it's on 90 degrees, and click on Update. And now let's click on Save. Let's add can 6, here shell number 6, and let's make it looks like let's say shell 1, no problem. And from here we will need to change the length, because shell number 6 is 650, Okay, so we will find it as 650, and for the longitudinal building line orientation we will make it 197 and click on update. Now let's click on save, and for the can number 7, let's make it looks like can number 5, and it's with 1.5 meters length. No, it's 1,250. That's the length, and the longitudinal building line orientation it's okay. And for can number 8, shell 8, let's make it looks like can 5. So from here it's 150, and the longitudinal building line orientation will be 197, and click on update. And now let's click on save. Now let's add the last element, which is the top head, and we will make it looks like the bottom head, and click on save. And the only thing we will do here, which is removing the flip direction to make the direction of the head on the correct side. Now let's click on run the assembly to start creating the second can, which include 3 shell pieces. Shell plates is 3 plates as we defined on the SEG software. Okay, as you can see here, we have the assembly for all cans. After that, on that part, we will define the skirt parts, and inshallah on the next parts we will define the nozzles on the shell. And as you can see, if we take a look here on the general arrangement drawing, we have a tilted nozzle here. We have a manhole with davit as a horizontal nozzle. We have another nozzles with supports. So how to define those supports on SEG software? We have a top head nozzles, so we will need to define the top head nozzles, and one of them with a top davit. So we will learn on the second part of this video how to add those nozzles on the bottom head and how to make the saddle nozzle vents or skirt vents, nozzle opening and skirt access, and how to add an external item like the earthing plug. But on the first part we will discuss how to generate the main items and the support skirt. Now the can number 7, we have one more can, which is can number 8, which is shell 8. After that the top head will be generated. Okay, now as you can see, all cans generated and assembled automatically. Now the last step, which is the top head, as you can see, it's generated from segments, and each segment of those is a separate part. You can deal with it and get the weight of each segment if you would like, get the surface area for each part. Now you have a 3D CAD model, you can deal with it. Now we have the complete vessel, as you can see. Now let's add the skirt on the bottom head. So let's select the bottom head, and from elements you can figure that you have a list of elements you can add it to the bottom head. Let's select the skirt and define the name of this element as a skirt. And from here you will find 2 types. The first type is a shell from plate, and the second one the shell from pipe. Let's select shell from plate to define the inside diameter. Let's keep the values as they are, and the thickness. The thickness of the skirt is 24 millimeters. Let's check the drawing here. The skirt main thickness is 24, and here we have 3 cans. The first can here with stainless steel material and with the thickness 22, or the other cans with different thicknesses. as 24 and with a different lengths. So how to add those cans to SEG, and one more thing, which is how to define the longitudinal welding line orientation per each can. Okay, now let's come back to SEG and fill those values. Here, the first longitudinal welding line orientation on the bottom can, the last one here, it's at 24, and the total length of this can is 5 meters. Let's take a look to the drawing here. The total length of this can from the tan line to the bottom of the base plate, it's 5 meters. So the total length is 5 meters, and here the gap, let's keep it 2. And for the material, let's take a copy from this material. Let's take a copy and paste it here. And the number of longitudinal welding lines per that sheet, if we take a look, we have 2 longitudinal welding lines on that can. So let's define them as 2. And for the second, the first skirt plate, we need to select this part, and from here we will need to define the material of that one. So we will take that material, okay, define that one, and the length, as we can see, it's 1 meter. So let's define it as 1 meter. And from here, the longitudinal welding line orientation for this can, we can check it from here. So it's at SLS 103. So let's come back here. SLS. So we may assume it at let's assume it at let's say 45 right now, and the blade thickness of this can is 22. It's not 24. So if we come back here to check, the thickness is it's 22. So we will need to define the thickness of this one, and here we have 3 longitudinal welding lines. And from here, let's select another skirt, and from here let's define the material of the second part. So that's the material of this one, and the length of this can is 1450, and the longitudinal welding line orientation, let's assume it on 90 degree, for example, right now, and we could modify it after that. And the thickness is 24, and the number of longitudinal welding line orientation is 2. We have 2 longitudinal welding line orientation. Okay, now let's add the dimensions of the base ring. Okay, the base ring inside diameter, if we take a look to that detail, we can get the inside diameter and outside diameter and whole circle diameter from this view. So let's define the inside diameter of the base ring, the outside diameter, and here that's the thickness of the base plate, it's 50 millimeters, and the bolt circle diameter is 4168, and the hole diameter it's 99, and the number of holes, so let's take a look to the number of bolts per quarter. So it's 1, 2, 3, 4, 5, 6, 8, 9. We have 9 bolts per quarter, so it's 36. So let's add here's the number of bolts like that, and the material of the base ring, let's select the same material here. Okay, and if you would like to add a pipe sleeve, you can add it from here. Now let's add the support ribs. So from here, the rib spacing is 135. If we take a look to that detail, sorry, here that's the detail. Okay, so that's the spacing, and the bottom width is 210, and the height is 310, and the bottom width is the same of the bottom width, and the rib thickness is 20. And let's change that material, and we have a top ring, so the radial width is the same, and the hole diameter is 99, and here's the blade thickness of the top plate is 40 millimeters, and here the material of that one. Now let's add a tailing lug. So from here, let's add the tailing lug, give it the same material, and the top width of the tailing lug is 300. And for the that's the bottom width, and same for the top width, and the lug height is the same of the spacing between the top and the bottom ring. And here the lug thickness is 40 millimeters, and the lug angle is on 90 degrees, and the radius is 155, and the hole diameter is 75, and the hole offset on the half thickness 155, and the hole offset from the end it's on from the end it's 155, but that value will be 300, like that. And actually we have two tailing lugs. Now we can define the spacing between them as 710, and if we have a cooler as per this drawing, we have cooler here around this lifting lug, so we will add it. So the inside diameter of the cooler, let's change the material, and the inside diameter will be the same inside diameter of the bin hole, and the cooler outside diameter 160, and the thickness, let's make it let's say 16 millimeters. Okay, and click on save. And if you have a bracing beam, you can add a bracing beam from here. So, but the available shape here is hot roll the section as HEA or IBE, not a pipe. Here on that model, you can figure that it's a pipe, not an HEA or an HEB or I section or H section. So that configuration, we can make it manually by using the features of Autodesk Inventor. Okay, so let's remove that one and click on save. Now let's click on start assembly to start creating the skirt components and assemble it to the final assembly of the vessel. Here that's the first or the bottom can on the skirt, which include, as you can see, two longitudinal welding lines, and here that's the base plate with the holes, and we will make a modification on the hole of the base ring to make it as a slot hole, not a direct or a straight hole. Something like that you can do, make it easily, but let's finish the assembly of the skirt. Here that's the top can, and here the intermediate can. As you can see, we have two longitudinal welding lines on the mid can, but the top one we have 3 cans. Finally, we will generate the lifting lug with the defined spacing here. Now we have the skirt. If we take a look, we have the skirt with a 3 longitudinal welding line orientation on the first can, and for the second and third can it will be like that. And here we have, as you can see, we have the tailing lugs will be like that. Okay, now let's go to another part, which is modifying the base ring. So let's open the skirt and make a little bit modification on the bottom ring. Let's open it here, and if you take a look, you can figure that the bottom plate include a slot hole. It's not a direct hole, so we need to make a modification on that directly. So let's keep that pattern like that, and from here let's make a modification and project this one, and from the slot holes let's select a hole like that. Okay, and let's make that hole equals that one, and finally we will make that line cross along that one. And as you can see here, the orientation of this one will take as the same orientation of that one. Now the last thing, we will make that diameter equals that one and define the length of this one to be, let's make it 100 millimeters, for example, or make it a little bit longer, sorry, 150, like that. And finally, let's click on extrude cut. So let's make it extrude cut on the two sides through all, so the hole will be like that. Now let's select that one, and during selecting the pattern, let's select the extrude feature, and now we have the base ring will be cut like that. Okay, as you can see, we make that modification. Now we have one more item. Let's add it to the skirt, which is the top washer, and inshallah we can continue with the next part by adding the washer to the skirt and adding the as mentioned the earthing plug to the skirt. After adding the nozzles, we can make the skirt vents, skirt opening, and skirt access. Okay, thank you for your time, and inshallah waiting for you on the second part of this tutorial video. Have a nice day. Assalamu alaikum warahmatullahi wabarakatuh. In this part of the tutorial video, we will discuss how to add the washer to the top ring of the skirt, how to add the bottom head nozzle with an elbow, and how to define the projection of the nozzle and the projection of the pipes, and how to add skirt opening and skirt vents and skirt access. Okay, now let's add the skirt washer. So from here, let's select the bottom head, and from here select the vessel, and from here select the shell can, and let's add a connection point as a skirt to make. Okay, and from here let's select it as a shell from a connected nozzle, connected point for a nozzle as a shell. Let's define the diameter of this one, and the thickness will be the same thickness of the can, and let's click on save. And now let's move it between the bottom head and shell one. So from here, let's come from move and move after the bottom head. Okay, now it will be moved between the bottom head and the can one, and now we have an unreal element. It looks like the shell, so we can use it to add the washer or add the skirt vents and access. Okay, now let's select this one, and from the external attachments, let's select the washer. Okay, name it as a skirt washer, and from here you can select it a rectangular or circular washer. So let's select rectangular washer and define the length and the width of this washer. So let's take a look to the washer detail here. It's 140 by 140, and the thickness is 16 millimeters. So from here it's 140, and the width is 140, and the thickness is 16, and the hole diameter, let's check the hole diameter, it's 68. Okay, so from here it's 68, and the bolt circle diameter, it's the same bolt circle diameter here, it's 4168, and the location we can measure it from here. So it's the distance from the tan line to the bottom of this washer. So let's get the distance up to here. So it's 4640. So it's 4640. Okay, and the orientation is 5 degrees, which is the number of holes, like that. So it's 5 degrees, and here let's keep the material like that, and here's the number of the anchor bolts. And now let's click start the assembly to start creating the washer. After that, we will check if the location is and the orientation is correct. If there is any issues, we will remeasure and define it again. As you can see here, the location of the washers come to the up direction. Because here we between the head and shell, we add unreal element here as a shell. And when you define the location with a positive value, it will be moved up. Actually, we need to make the location with a negative value to get it down here. So the location here, we will need to define it with a negative value to move the washers to the other side. Okay, and here as you can see, here we need to increase this value. I may not measure it in a correct way, so we need to increase this value with 10 millimeters. So we will make it like that. And now let's click Start Assembly to update the washer location. Okay, and now the washer will be located on the right place. It's a rectangular washer. Okay, on the skirt. Now let's add the nozzle F to the bottom head. Okay, so if we take a look to the nozzle information here on the nozzle table, as you can see, it's 16 inches, but it's a from plate. It's a nozzle from plate. So how to add a nozzle from plate to the bottom head? From here, let's select the bottom head, and from nozzles, let's select the head nozzle and make it nozzle F. And from nozzle F, let's select a nozzle from plate instead of nozzle from pipe. So let's select from here nozzle from plate and define the outside diameter of this nozzle with the same diameter of the standard pipe. And here the thickness, and here the longitudinal building line orientation, the gap and the offset from the vessel center line, it's on the center, so the offset will be equal 0. And here the material of the plate, we can change it to take the same material of this part as a stainless material plate. And let's put that value here, and we have a rebad. The rebad information, it's the rebad width for F1, it's 180 with 25 millimeters thickness, 180 with 25 millimeters thickness, and here's the rebad material, and the name of this one is outlet nozzle, and keep on save. The projection, we will keep it right now until adding the elbow to measure the projection in a correct way. As you can see here, if we take a look to the right side here, the projection of this nozzle, okay, measured from the tan line, and here we have this center line from after adding this elbow. So let's add the elbow first. So if elbow, okay, and from here let's select that elbow and select elbow 90 degrees long radius and define the size is 16. And here's the thickness of this elbow is user defined thickness is 10 millimeters, and the orientation we will keep it at 0. And now if we come back to the nozzle, and from the calculator we can calculate the projection. Here it's 1800 from the tan line. So if we take a look to the image here, in SEG the definition measured from the seam line. So we will need to add more 50 millimeters for the straight flange. So the total value will be 1850. So from here, let's click on calculate to calculate the required length. In that case, SEG will create a sketch to calculate the actual pipe projection. So when you click on save, now you will get that elbow. So when you click on start assembly, you will start creating the nozzle as a nozzle from plate. So the neck will be from plate, so you can get plate development for this part and the rebad for this nozzle. Okay, so let's take a look from the front view. Okay, and take a look from here. Now we have this nozzle with that elbow. Now let's come back to the AutoCAD drawing, and here we have two pipes. Pipe from plate, it's not a standard pipe. So the first pipe length is 283, and the second pipe length is it's 1250. Okay, so now let's add two pipes. So from here, let's select the external connection point and let's add if pipe 1. Okay, and from here, let's select shell, and in that shell, let's define the or select a welded pipe. So we can select the size of this pipe. It's a welded pipe, so it's 16 inches. And from here we can define the thickness. So it's 10 millimeter the thickness, and the length is 283. So it's 283. And from here the longitudinal building line orientation, we could keep it 45, and the gap as 2. Now let's add another pipe, which is F pipe 2. Okay, and click on we could make it looks like pipe 1, and from here we can change the length. It's 1250, and the orientation we can change it as 135, and click on save. Now let's add the last part on this nozzle, which is this flange. So let's come here, and from elements let's add a flange. So if flange. Okay, and this flange we will define it as a weld neck raised face according to ASME P16.5 with rating 150, and the size is 16. And the schedule, we will remove it and define the thickness as 10 millimeters at the end, and click save. And we can define the material as we discussed by typing it on this text box or getting it from the material library. Now when we click on start assembly, we will start creating the first pipe, which is connected to the elbow, and the second pipe with the other longitudinal building line, and here finally the nozzle with the flange. So as you can see, we have this nozzle goes outside the skirt. Now we need to add a skirt opening to this skirt. Okay, so how to make an opening on this skirt? Okay, so let's come back to the AutoCAD drawing. Here we have a skirt opening 1, SO1. So let's check the size of this one on the nozzle table. It's SO1. So the inside diameter is 617. Okay, and with the thickness 24 millimeters. Now let's select the skirt connection point to use it to add nozzles, and select nozzle type B, which is give you the ability to make a nozzle with internal and external projection. So we can use this type of nozzle to make skirt vent, skirt access, and skirt opening. Now let's select it, and SO1 like that, and from here let's select it as a nozzle from plate and select the pipe OD. So the pipe OD, so let's calculate the pipe OD. It's 617 plus 48. So that's the outside diameter of the pipe. So that's the OD, and the thickness is 24. And let's keep the orientation as 42. And the location, as mentioned, we need to add the location with a negative value. Okay, and this value measured from the seam line. So here the value is 1,800. So we will need to define this value as a negative 1,850. We need to add the straight flange value here, and we will give it the orientation of the nozzle, and we will need to copy the material. So let's copy the material. It's the plate material, and paste it here. And here, regarding the projection, it's a skirt opening. Okay, that's the surface of this one, and the projection we can measure it directly from here. So if you come here like that and measure that one, it's 7.9, and for that one it's 50. Okay, so 7.9. And for the external projection, we can do it by another way, which is if we measure the value from here to there, which is the outside diameter, it's 3. Let's measure it to the center line from here there. Okay, so we need to add 50 millimeters to that value. So that's the external projection from the vessel center line. So by using the calculator, we can calculate that value directly from the calculator to give us that value. So let's change that value to be like that. Okay, and click on save. Now the projection will be automatically calculated here with 50 millimeters. Now let's run the skirt opening to generate it on the skirt as a nozzle or an opening from plate with 24 millimeters thickness. As you can see, now we have this cut on, this opening on the skirt like that. Now you can make a cut manually to the skirt. So let's go inside the skirt and let's go to inside that part. From here we can select that plan or directly select a sketch and create a sketch here by using the pipe. So from here we have this sketch. So let's make it a construction line, and from here let's make a gap of a cut with 2 millimeters or more if you would like to make it 4 millimeters. So from here let's make extrude cut to next or to next. So the cut, let's define the distance. Sorry, let's define the distance as, let's say, 1 meter, for example. And here we have a cut on the skirt for that one. So let's open this one and hide the plan, the work plan. Okay, now we have this cut on the skirt. Let's close this. Now we have the opening on this skirt like that. Now we need to add a stiffening grips on this pipe. As you can see here on this pipe, we have a stiffening plate here. We need to measure the width of this one. It's 80 millimeters, and the height is around 150, and the location from the beginning of the pipe or from the start point of the pipe, it's around 1015. So from here let's select this pipe, which is the second pipe, and from element let's select the external element and select the longitudinal blade. So let's define it as F support blade, and let's click add, and from here let's select a longitudinal blade, define the height. So the height here is 105, and the thickness, let's keep it 10 millimeters, and the location is 1015, and the orientation is at 0, and the width will be 80 millimeters. And from here let's activate the rectangular pattern, circular pattern, sorry. And from here we will add 3 stiffening reps. Now let's click on start assembly to start creating the stiffening grips on the pipe. So let's take a look here. So as you can see, here we have this stiffening grip. If we take a section on the longitudinal direction like that, so as you can see, we have this one, or this stiffening grip, as one more thing, the location measured from the center line of this one, not from the surface. So we need to increase the value. So that value should be, let's measure it from the center of this one. So to be like that, 1055. So it will be like that, and click on save. Now let's start the assembly to update that value. Okay, now the stiffening grip drawn, we draw it in a correct location. Now, as you can see, we have this skirt opening by that way. Let's remove the cut of the half section, and now let's add the skirt vents. Okay, we have 4 skirt vents from SV1 up to SV4. Okay, and here we have the location and the orientation. Let's check the orientation of the skirt vents. The first one on 45 degrees. Okay, and we have 4 equal vents. So from here, let's select a nozzle with internal and external projection. So from here, let's add this one. So this is the skirt vent 1. It's so from the nozzle table, let's check SV1. Here it's 4 inches with a schedule 40S. So from here, it's a nozzle from pipe, 4 inches with a schedule 40S. Okay, and the location, we will add it with a negative value, 600 plus the straight flange, so it will be 650. So negative 650, and the orientation is 45. And here let's keep that value as it is. And for the internal projection, let's make it 50. And for the calculator, let's make this value we calculated. So this one 22. Okay, so it will be like that. So we can take that. We can keep that one, and you can take a copy from skirt event 1 and make a paste here. Be like that, and just make a rename for the skirt event to be skirt event 2, and click rename, and you can add one more skirt event, which is skirt event 3. After that, we can change the orientation for each one after adding them. So let's add the third one, skirt event 4. So let's come back to skirt event 2 and change the orientation 135. Okay. And finally 350. And now let's run the assembly to add the skirt vents. After that, after adding the skirt vents, we will make a cut on the skirt based on the skirt vents location. After that, we can add the skirt axis. Here, that's the last skirt vent. Okay, now as you can see, now we have 4 skirt vents. So we can make a cut on that skirt based on that one. So from here, let's make a sketch and print the outside line and make another cut. Define the cut gap, so we can make it as 2 millimeters. Okay, so from here we can open this part and we can make this plan visible and make a circular pattern for this one along this one with 4 typical parts and close it. So now we can get the skirt vents along the skirt. Now let's add the skirt axis. Now we have this skirt axis. We have 2 skirt axes, skirt axis 1 and skirt axis 2. And if we come back to the nozzle table and skirt, check the skirt axis, it's the inside diameter, so it's a front plate with 26 millimeters thickness with 450 millimeters inside diameter. So from here, let's select the connection point, and from here select the nozzle with external and internal projection. So skirt axis 1, and for that one, let's select it from plate and define the outside diameter. So here it's defined by the inside the inside diameter 450, so it's 450 plus 26 plus 26, so it's like that. So that's the outside diameter, 26 as the thickness, 45 the location, and finally the location of this skirt axis. It's located on 5130, so we will add 50 millimeters plus that, so it will be 1180, 4180, like that, and the orientation will be on, I think, so it's a skirt axis 1, it's at 180, and for the axis 2 it's at 0 degree. So from here let's add it on 180 degrees, and the material, let's add the material of the plate, that one. From here let's add this one, and skirt axis. Okay, and click on save, and we can measure the internal projection from here. So let's come down here and measure the internal projection. It's 86, so let's make it 86. And for the projection on the outside, we can make it like that. Okay, and click save. Okay, and now let's we need to add the location with a negative value. I forget to add the negative value, and now let's click save. Now let's take a copy from this one and paste it. Okay, and name it as skirt axis 2. Okay, and click rename to rename it. And now we need to make a refresh and come back to this nozzle and change the orientation to 0 degree and click on save. Now let's run the assembly to create the first and second skirt axis. It's a pipe from a plate with a welding line. And here the second skirt axis. Okay, now we have those axes like that. So let's go inside the can by double clicking on it, and now let's make a sketch by selecting that surface and click F5 to redo for view, undo for view, and from here let's select the outside diameter, convert it to a construction line, draw a skirt and give a value for the cut and make it cut through all, and save that one. And let's open this skirt axis and hide the work plane, make it invisible, and click on save. Now we have the skirt axis with two openings, as you can see. Here we have that opening on that side and the other opening on the other side. Okay, now as you can see in this part of the tutorial, we create the washer on the skirt axis. We add the nozzle on the bottom head. Let's take a section, a half section here. We add the nozzle to the bottom head, and we discuss how to calculate the projection for this nozzle from the seam line of the head, how to add this nozzle as a nozzle from plate. After that, we add stiffening grips for that nozzle inside the skirt opening. We add 4 skirt vents, and we learn how to make a copy from a part and add it to the same parent. Okay, inshallah, on the third part we will discuss the other types of nozzles on the shell and on the top head. Thank you for your time. Have a nice day. Assalamu alaikum wa rahmatullahi wa barakatuh. In this part of the tutorial video, we will start creating the shell nozzles. And here we have some nozzles on the shell cans. We will start with nozzle N1 and N2. Here, if we take a look to the bill of material, and select nozzle N2. It's 2 inches, okay, and it's a utility connection with ATS schedule, weld neck raised face flange with rating 600. And here's the projection from the visual center line. Okay, now let's select the first can. Sorry, that's the first can. Let's minimize this, and from here let's select the first can, and from here let's add N1. Okay, so from here let's select N1, and it's a nozzle from pipe with 2 inches with schedule ATS. Okay, and the location here, if we take a look to the elevation view, it's 200 millimeters from the tan line. That means it's 150 millimeters from the seam line. That's the value SEG can understand. So from here, let's define the location, and from the top view, let's check the orientation. So we're here as an N1 on orientation 70. So let's change the orientation, and from here, it's a utility connection. That's the service of this nozzle, and let's click on save. And from here, let's select the nozzle, and let's select standard nozzle and N1 flange. From here, select it as a weld neck raised face according to ASME B16.5. The schedule is 600, and the size is 2 inches with the schedule ATS, and click on save. Now, if we come back again to nozzle N1 and open the calculator, now we can define the projection. So let's check the value on the nozzle table. So that's nozzle N2. So the value 2185. It's 2185. And let's click calculate. So that's the projection of the nozzle. Now let's click assembly, and now let's click start the assembly of this nozzle. We will add a stiffening grip to this nozzle. So if we come here to that view, as you can see, we have a stiffening grip here to this nozzle. So we need to select the can 1, and from elements let's select external attachment, and from the external attachment you will find here a stiffening grip and a stiffening support. So we will need to add a stiffening grip, so it's N1 grip, and from here select N1, and as you can see, you can add a stiffening grips to the nozzle, the shell nozzle, as you can see, up to 4 grips, and you will find here some different configurations for this stiffening. So let's select that configuration, and from here let's define the outside diameter. It's 2 inches, so that's the outside diameter of the 2 inches. And from here the rib width, so let's measure the width of this rib. So from the home, let's measure the distance from here up to there. So it's 40 millimeters. Okay, so the and thickness, let's make it 6 millimeters. And the rib angle, we need to measure the, let's measure the angle of the, okay, so let's measure the angle. So from here, let's measure this angle. It is 30, so it's 30 degrees, and the location, the same location of the nozzle, and the orientation, it's the same orientation of the nozzle. And here's the material, and it should be so let's make it SA 4 600. It will be like that. And from here the rib offset, so the offset is measured from the end of the pipe. So let's come here and measure this distance. So from here let's measure the linear value from here to there. It's 22 millimeters, so it's 22. And the projection, it should be the same projection of the pipe, so we will get the projection from here. Okay, so as you can see, the projection, we will need to add the projection of the pipe here, and it's a radial nozzle. And if you would like to add some other ribs, you can do that. Now let's click save and click start to add a rib to this nozzle. Now we have this stiffening grip. It will be like that. So we may need to add a rib to another rib to the perpendicular side. It will be like that, and the angle will be 30 degrees, and the offset will be the same offset. It's 22. And now let's click save and run. Now we have this stiffening rib here at the top of the nozzle, like that. Now let's add another nozzle, which is N2. Okay, and now let's check N2 orientation. So if we take a look here, N2 at 200 degrees. So let's take a copy from N1 and make paste, like that. And the same from the rib. Let's take a copy from that rib and make paste. And now let's rename those items. From here it's N2 and click on rename, and from here N2 flange and click rename, and from here it's N2 rib and click on rename. Now let's change the content. So the orientation of this nozzle in 200 degrees, and the same for the flange will be keep it as it is, but for the rib we will change the orientation and give it the same orientation of the nozzle, and click on start assembly to start creating nozzle N2. Okay, until finishing the updating of this nozzle, let's go through the nozzle C1 and C2. Okay, here nozzle C1 and C2, it's 12 inches. Okay, and here that's the name of this nozzle. So let's take a copy from it. It's the service, and it's from blade with 10 millimeters the thickness. So here I think the assembly is done. Now we have that's the first nozzle, and here the second nozzle. Now let's add nozzle C1. So from here let's select shell 1 and let's add another nozzle C1. Okay, and from here let's select a nozzle from blade. So that type, which is nozzle from blade, and we need to define the where's C1 and C2. It's 12 inches, so we need to check the outside diameter of the 12 inches. So we will need to open the array, and from here that's the outside diameter. Okay, so from here let's define the pipe OD. Okay, and the thickness is 10 millimeters. Here we have the longitudinal welding line orientation and the location of the nozzle. Let's come here. So the location will be on 690. So we will decrease 50 millimeters of the straight flange, so it will be 640. So it will be 640. And for the orientation, we will need to check the top view for C1. So where is C1? C1 at 0. Okay, so we will keep it that one at 0. And from here, that's the surface of the nozzle. And from here, it's not a radial nozzle, it's a tilted nozzle. So we will need to select this one. And from here, we will make it 45 degrees and click on save. Okay, now let's check the tilted angle direction, if it's okay or not. To update it on the model, to check it first if the direction is okay, or we need to change the value. So that's the 45 degrees. Okay, it's like that. So we need to add a flange to this nozzle. So from here, let's select this external connection point and add C1 flange, like that. And from here, let's select a welding raised face according to ASME, and let's check the rating and of this flange. It's 150. Okay, so it's 150. So from here, let's select keep the size to be 12 inches and 10 inches at the end. Click Save. Now let's add a gasket. So from here, let's see one gasket. It's 12 inches. Now let's add blind. C1 blind. So from here, let's select blind with a raised face according to SMA 16.5 and make it flipped. And now let's run the assembly. Now let's come back to the AutoCAD drawing. Here, as I can see, we have a reinforced bed for this nozzle. We forget to add it, so let's come back here and check the value of this reinforced bed. It's 210 with 22 millimeter thickness. So we need to come back to this nozzle again. From here, sorry, let's check the value again. I may forget, it's 210. Sorry, with 22 millimeter thickness, as I remember. Yes, it's 22. And for the material, we can search for that one and select the material like that. And regarding the projection, we could measure the projection from a quick drawing. Okay, because here, as I can see, the projection is not defined here, but it's maybe defined from here, from the outside surface of the shell to the facing of the flange. It's 500 millimeter. So we need to update this projection and make it the same. So from here, let's 50. And now let's check the projection. So let's measure it from here. So let's make a sketch, print this line. Let's add circle here. Click Finish. Now let's measure from here to there. So we need to increase 85 millimeters to this nozzle. So from here, let's increase that value to be like that. Okay, and now let's start the assembly to start modifying the nozzle by adding a rebed to this nozzle and changing the projection of this pipe to make the final projection is 500 millimeters. Now let's check the drawing again. Now, as you can see, the projection is updated to 500 millimeter from the outside surface of the shell to the facing of the flange. Now let's add another nozzle like that. But before that, as you can see, we have here a hand grip and hinge support to this nozzle. So to add that by using SEG, we need to select the blind flange, and from the elements, let's add a hand grip. So C1 grip. Okay, and from here, let's select the first one. You will find different types of hand grips. We will select the first type and keep everything as it is. And the offset, we will keep it at 0 and click on Save. And now let's click Start the assembly to check the location and the orientation of this hand grip on the cover. Okay, it's okay. Now let's add a hinge support. So from here, let's select this one. And from elements, we can add a hinge support. So from here, let's select C1 hinge. Okay, and by selecting it from the tree, we can select a detailed manhole hinge. Okay, so you can select this one directly and modify the value. So we can select 12 inches. And here the size and the orientation, let's make it at a 0 degree, and let's keep everything as it is and click on Start Assembly to start creating this one. Okay, as you can see, each part on the hinge is created and assembled on the final assembly of the cover. Here, if we take a look, as you can see here on that type of hinge, so that means we will not need this hinge, so we can delete the C grip, okay, and keep that one. And we can modify the orientation of this one. So the orientation, we could make it on 90 degree and click save. Now click on start simply to update the hand grip. Okay, but after doing that, we can add stud bolts to this one, and by taking a copy from all of this nozzle, we can make nozzle C2, which include the flange, gasket, cover, the hinge, the cover hinge, and the stud bolts. So we can take a copy from all of that in one time. So I think we need to flip the direction of this one. So let's change to be like that. And now let's add stud bolts. So from here, let's add C1 stud. Okay, and from here, let's measure the nut spacing. So let's take a copy from this. And from here, let's open the flange and open the bolting. And from the bolts, sorry. So here we have the size, and here we have the length. So from here, let's select the size 7x8, and here that's the spacing, and here's the length. And let's click on save. And now let's start the assembly to start modifying the hand grip. After that, start modifying the or creating the stud bolts. So here, after creating this assembly, you can figure that here's this nozzle with this hinge with the stud bolts. Now we can take a copy from all of this nozzle, which is C1, and create nozzle C2. So copy and make a paste here, and make a rename for all parts. So let's rename this as C2 and save. After that, select this flange and make it flange C2 flange, and remove those numbers and rename. And for the gasket, it's gasket C2, and remove that part and rename. The same for blind, it's C2 blind, and remove that part, click save. And finally, the hinge, it's 2, click save. The last piece, stud bolt, and click on save. Now let's change the orientation of the nozzle C2. So let's take a look to the top view of this nozzle. So here nozzle C2 located on 180 degrees. So the orientation will be like that. And from the assembly, let's start creating the assembly. Okay, here, as you can see here, we have the second nozzle. Now let's add, we have 2 more nozzles on this can. The first one, which is T1, TL1, and TL2. Okay, so we will take a copy. It's the same definition of nozzle N1 and N2. So let's take a copy from this one and make paste. Okay, and from here let's take the nozzle name. Okay, and here's the nozzle name. Let's change it to be like that, and change the location and orientation based on this drawing. So the T1 location, it's located on 3200, so we will decrease 50 millimeter of the straight flange, so it will be 300 and 150. And the orientation, let's check it from the top view. It's T1, it's on 20 degrees, and let's click on save. Now let's take a copy from the rib. Okay, and paste it here and rename it as TI1. It's TI1. Okay, and remove that part. And let's take a copy from T1 to make it TI2. So copy and paste. And rename this one. Okay, and let's remove that part, and the same thing for the flange. Okay, and from here let's change the location and orientation. So let's check the orientation, which is T2. Where is that one? It's T1, 2. Okay, it's on 335. And the location, it's on 7700, so we will decrease 50 millimeters and click on save. Now let's define the location of the first rib to be the same of that one. So let's take a copy from location and orientation. It's on 20 degrees. So here that's the location and the orientation is 20. And let's take a copy from this one and paste it on the shelf. Okay, and from here let's rename it and remove that number. And now let's refresh the view and come back to this one. Take the location and the orientation is 335. So let's change the location and the orientation. Save that and start the assembly. Okay, here we have those two nozzles. That's the first nozzle, and here the second nozzle. It's like that. Now we have one more nozzle, which is a manhole. Okay, it's a nozzle from pipe. So let's check M1 on the bill of material. M1 is 24 inches from blade with 10 inches with 10 millimeter thickness. Sorry. So from here, let's select can 1 and select this type of nozzle. And from here, select nozzle from plate and define the outside diameter and the thickness, the longitudinal welding line orientation, and here's the location of the nozzle. It's 1250, so we will decrease, so it will be that value. I need to edit it. And finally, the orientation of the manhole, so it's 270, so it will be like that. And let's add a flange. So from here, N1 flange. Sorry, M1 flange. So if we have the same name, which is M1 flange. So from here, let's select the rating, select the size, and in the thickness is 10 millimeters, and click on save. Now let's add a gasket to that one. So it's M1 gasket. So from here, let's select this type, size, and save. Let's add a cover, M1 blind, and select that type, select size, and make it flipped. And now let's add stud, M1 stud, and select type, size, and the total length and the spacing. Finally, let's add the M1 davit and click on save. Now from here we can select the suitable configuration for the davit. So you have many different configurations. So you can select the suitable configuration for your case. We could select this one, select the rating, select the size, keep the orientation as it is, and now let's click on save. Now let's start the assembly. Let's change this value to make it like that, and click on start the assembly. One more thing, I forget to add a wear plate, so let's stop the assembly and check the wear plate of this nozzle. So here on M1 we have a reinforced pad with 280 with 22 millimeters thickness. So let's come back to the nozzle and let's add a repad and add that one, and the name is manway, and click on save. Now let's start creating the update the manhole with a repad. One more thing I would like to update it, I forget to update it, which is the projection of this one. So from here, the projection of the manhole, we can check it from the table. It's 2225, so we could stop that. Okay, after finishing, the flange, I think the flange itself is not with the right size. 24, click save. Now when we come back here and open the calculator and click the correct projection, now we can start updating the manhole projection and update the flange size. So here we have this manhole davit. We need to rotate it. As you can see, after generating this, inshallah, we can, on the next part of the video, we will add the top head nozzles. Okay, and after that, we can add the top davit and the external attachments and adding the lifting trunnion. As you can see, for the manhole davit, we can change the orientation to make it suit the orientation of the manhole, and inshallah on the next part we will complete adding the top head nozzles, and on the next part we will have the top davit with the external attachments. Assalamu alaikum warahmatullahi wabarakatuh. In this part of the tutorial we will learn how to add the top head nozzles. In this vessel we have 4 nozzles on the top head. Let's start with nozzle A. If we take a look to the nozzle table, it's 24 inches. Okay, and it's a front blade with 10 millimeters the thickness, and the flange is a Wildenich raised face flange with a rating 150, and here the reinforced bad width and reinforced bad thickness. Okay, now let's go to SEG software and select the top head, and from elements let's select this type of nozzle, and let's add the nozzle name, which is nozzle A. And from here it's a nozzle from pipe, so let's select the second type, which is nozzle from blade connected to head, and define the outside diameter. And here's the thickness, the longitudinal bonding line orientation, here the gap, and the offset from vessel center line, it's 0. Let's add an enforced bed. Here it's 245 with 25 millimeters, 245 with 25 millimeters thickness. And here we can change the material to stainless steel material. So from here, let's click on Save, Details, and come down here and select that grade, and take a copy from that one and paste here. And we could take the surface of this nozzle as a copy and paste on this text box, and click on Save. Now let's add a flange to this one, so it's a flange. Okay, and from here let's select the flange and select the size of the flange, and select the size from here, and define the thickness as 10 millimeters. Click on Save, and now let's come back to the nozzle and change the projection. If we come back to this detail, as you can see, the projection here is 1600 measured from 10 line, so we will increase 50 millimeters to this one to be like that, and click on Calculate. Now SEG will start creating a sketch to calculate the projection of the nozzle, and it will be reflected here, and click Save. Okay, now let's create this nozzle on the top head. Now let's add another nozzle to the top head. We have nozzle A. Now let's add nozzle AN. So from here let's check nozzle AN. Okay, it's 8 inches. Okay, and here the schedule is 40S. So let's take a copy from the surface of this nozzle, and now let's add AN. It's AN nozzle. It's a nozzle from pipe with 8 inches, and the schedule is 40S. Okay, and the offset is 1 meter. Okay, and let's come here, change that one to 1 meter, and let's add a reinforced bed. It's 60 with 25, so it's 60 with 25 millimeters, and here that's the nozzle surface. And for the material we can make a search and select the grade to be like that, take a copy and make paste here. After that let's add a flange, AN flange, and select this one, select, keep the rating, I think rating is 150, yes it's 150, and the size is 8 inches, schedule is 40S, and click on Save. Now let's come back here and modify the projection, and click Calculate. Now the projection of the pipe will be calculated. Okay, and let's click on Save. Now let's add a gasket. So from here it's AN gasket, and let's define the size, click Save. Let's add blind, AN blind, select the size, the type of the blind flange, select the size and make it flip. Okay, and now let's add or let's run this simply. Okay, here we have nozzle AN. Okay, let's measure the nut spacing. Let's take that copy, and from here for 8 inches it's 3 by 4 and the length 110. So let's add a stud, AN stud, select the size. Here's that one, the nut spacing, and now let's add another nozzle, which is nozzle V, which is the vent. So let's come down here, and it's 3 inches. It's pipe with scalable ATS. So from here let's add nozzle V, and it's pipe 3 inches as ATS. Okay, and with offset 1 meter. And here regarding the orientation, I think I forget to add the orientation for nozzle AN, and the same for V. So nozzle V with a rebad, I think. Okay, it's with a rebad or not? It's with a rebad, yes, 60 and 25. So let's activate this, 60 and 25, and we could take the service from here as a vent. We can write it directly and click on save. And now let's check the orientation for AN and V from here. So AN nozzle is located on AN nozzle 307. So let's, after saving this, let's come here. It's on 307 and click save. And for the vent, it's located on 340. Okay, and let's click on save. And from here, let's add a flange to the vent. So V flange, and defined the type of the flange, and let's check the rating. So V with the rating 300. So the rating here is 300 and the size is 8, and the scalable ATS, and click on save. Now let's come back to this flange and calculate the projection from the seam line. And click on save. Now let's update the orientation for nozzle AN and create nozzle V. Okay, here we add both of AN nozzle, and that's the flange of the vent nozzle. Okay, here we have those nozzles on the top head. As you can see, the size is not correct, so we need to come back to the vent nozzle and change the size. It's 3 inches and modify it. So let's come back here and modify the projection and recalculate it again to update the projection of the pipe. So you will find here a value will appear. It's different from here. As you can see, it's 694, but here it's 662. So when you click on save, it will be reflected here. Now let's update this nozzle, and now let's check the final one until Autodesk Inventor SEG creating update this nozzle, which is V nozzle on Autodesk Inventor. Let's check M2 nozzle on the nozzle table. Here nozzle M2 is 24 inches, nozzle from plate with 10 millimeter the thickness, and here we have a rebad with 280 as a width and 25 as thickness. So let's come here, and from the top head let's add a nozzle as M2. Okay, and let's select M2 and select nozzle from plate. So define the outside diameter, the thickness, orientation, and the offset. So we need to check the offset. It's 120 millimeters, 1200. So the offset is 1200. And regarding the orientation, it's located on 220. Okay, and we have a rebad, and that's the rebad thickness. If you would like to modify that one, you can do that. Click done and copy that one here to there, and you can take a copy from the name from the nozzle table and paste it here and click on save. Now let's add a nozzle, a flange, so M2 flange. Okay, from here select the type, select size, and select the end thickness and click save. Now when we come back to the nozzle and modify the projection and click on calculate, the projection of this pipe will be defined. Here's the projection, sorry, it's 1650. Okay, now let's add a gasket, M2 gasket. Select the type, size, and save. Now let's add a blind. Select the type of the flange, select the size, and click on flip. Now let's add a stud bolt, M2 stud. From here, select this type and the size of the bolt. From here, the length of the bolt and the nut spacing. Click save. Now let's add a manhole davit. So we could keep the manhole davit until checking the nozzle location on the top head. Okay, here we have the all nozzles on the top head. As you can see, this rebad is intersect with the welding lines of the top head, and no problem with that. It can be covered by code and by inspection. Okay, now let's check something here regarding the nozzle sheet metal flat pattern. For example, for this nozzle from neck, we can get the sheet metal development for this plate easily, and the same for the tilted nozzle. For example, if we open this tilted nozzle, and if you would like to get the sheet metal development for this rebad, you can get it easily. As you can see, that's the sheet metal development for the rebad, and for the nozzle neck you can get it easily. Here's the nozzle neck, and here's the flat pattern for the nozzle neck. Okay, now let's add a manhole davit for this one. So from here let's select the blind flange, and from here select detailed manhole davit. So it's M2 davit. Okay, and from here you will find a list of davits, standard davits, so you can select the suitable configuration for your case. Here all of that is a horizontal covers. here some standard vertical covers, so you can select the suitable one for your design. Okay, and let's select that one, which is that one, and from here select the rating, select the size, and click on save. Okay, so here this is checkbox. If you take a look to the type B, which is a neck, weld neck flange, and if you have a slip-on flange, you can remove this checkbox. But in our case, let's select flange type B, and now when you click on Start Assembly, the top davit will be generated. And here we have the top davit on the vertical nozzle. Now, as you can see, we generate the vessel main items on the first tutorial. On the second part of this tutorial, we generate the bottom head nozzles and the nozzle openings like vents, access, and nozzle opening. On the third part of this tutorial, we generate the shell nozzles. Here we have a tilted or a helicide nozzle as a nozzle from plate, and we have a manhole and another 4 nozzles with stiffening grips. And on that part of tutorial, which is the fourth part, we create the top head nozzles. Inshallah, on the next part we will discuss how to generate the top davit, that davit, by using SEG software, and how to add a lifting trunnion and some other external attachments like platform clips. Thank you for your valuable time, and see you soon on the next part, inshallah. Assalamu alaikum. Assalamu alaikum wa rahmatullahi wa barakatuh. In this part of the tutorial, we will discuss how to generate the top davit for this vessel, and here we have the detailed drawing for the top davit. Now let's select can 1, and from the elements and from the external attachment you will find here an item called top davit. So now let's add the top davit. Okay, and from here let's select it. As you can see, you will find on this list the different types of top davits, so you can pick the suitable type for your case. Here we have 2 brackets, a bottom bracket which fixing the ball bearing, and another top bracket, and we have here a perpendicular pipe or bracing pipe and another bracing pipe, or a branch pipe and bracing pipe. The same configuration, but here, as you can see, with different diameters. The bottom clamp or the bottom bracket with a different diameter than the top bracket. Another type, which is type C, it's related to another standard spec, so you can use this type if it suits your requirements. Another type of the top davit, like that, and the lifting lug here is just a U-bolt, but in our case it's blade like that, so that type will not suit our requirement. And here another type. Now, so the nearest configuration here is type A. Okay, but here we have a slight projection from the branch pipe, and the bracing pipe has the same diameter of the main pipe, but in that case it has a different diameter. But no problem, let's use this type and start defining the dimensions. If we take a look here to this image, for the bottom bracket you will find 2 dimensions to define this plate, A and B, and here the projection, which is C, and E. So if we take a look to that view, we can extract those dimensions. So that's the minimum width, and here the maximum width. So let's fill the dimensions as per this drawing. So I will fill the dimensions to be like that. And here finally we have the top David on the vertical bezel. Okay, and now we could add some external attachments like external supports, platform supports. And now let's select, for example, CAN1, and from here and from external we can select external platform clips. So from here we can select platform clip. We can call it clip 1. And when you select this support clip, you will find different configurations for this support clip. One of them, which is the support clip type A, and here support clip type B, you have a double supports with spacing, and here for the third type you have a cross section like a C created from formed blade, and here for the type D, a single one. Okay, have a bracing like that, another stiffening clip like that. So you have many different configurations, so you can select the suitable type for your case and define it. Now let's select that one, for example, and define the dimensions of this one. So dimension A here is 420, and the width is 60 millimeters. That's the length, sorry. And dimension B, which is the width, it's 100 millimeter, and here's the thickness, the location here, it's 370. Okay, and for the projection, no problem, it's just loading. Here the width of the wear plate is 60 millimeter, and the length is 420, and the thickness, let's keep it 10 millimeter, and the fillet could be 15 millimeters, and the hole diameter and the hole offset, offset from the other side, C1 and C2, and here's the number of holes and number of columns. If you have more than one column, that's one column. If you have another pattern here, you can create this another pattern by duplicating that number. The column offset if you have another column, and that's if you have just only one, and that's in case in a radial. So if you have a heli side one, you can select that option, but in our case let's keep it like that, and here that's the location of this one, and let's click on save, and now let's start creating the assembly. So by that way, we have a support clip like that. So you can change the orientation of this one. So from here, let's modify the angle of this one. Let's make it on 120 and click on Start Assembly to modify the orientation of this one. I hope now we covered that's the start angle, sorry, so we could change the start angle from here. So let's make it 30 degrees. And if you have more than one support, so let's add 3 supports, for example. And here that's the first one and the last one orientation. So the first support will start on 30 degrees and that's the last one. And now we have 30. So the second one will be exist between those angles. So let's start the assembly to update this support clip. So as you can see, now we have 3 support clips like that with equal spacing on the angular direction. Now, as you can see, in around, let's say, 2 hours, we generate the complete 3D model for this equipment, and you can get a detailed bill of material for your equipment from here, from SEG bill of material. And here you have the total weight of the equipment. It's around 47 tons. Okay, and you have here a list of the items. You can export this bill of material as an XLSX file. So let's go to the project name, or we can add this file directly to the desktop. And if we come here and open this file, here we have the bill of material. So let's select those columns and hide them. So we can hide that. And here we have the bill of material of our project. Here the item number, here the quantity, and here the description of the item and the technical characteristics of each item and the material of the item and the weight of each item. Okay. I hope in this tutorial we covered the 3D modeling for this equipment, and inshallah on the next tutorials we will discuss another equipment. So if you have any questions, kindly contact us. Have a nice day. Assalamu alaikum. Assalamu alaikum wa rahmatullahi wa barakatuh. In this part of this tutorial, we will discuss the difference between the shell development drawing faces the 3D PDF, and how we can easily export our 3D model in a 3D PDF, and how we can deal with this 3D PDF and measure the dimensions from it. Okay, here, as you can see, here that's the shell development for the shell blades, and here the development for the skirt. And as you know, on the skirt, for the rings you have different diameters. It's not the same diameter of the skirt. And here the bottom head and top head with longitudinal welding lines and the nozzle locations. Now, in the Autodesk Inventor, by the help of SEG software, we generate the 3D model for this equipment, including all attachments that we need, as you can see. And if you would like to check if you have any clashes or something like that, easily you can go and measure the distance between, for example, that line or that point and that line and get the value directly. And you can send a 3D PDF for your client, and if you would like to add any comments or something like that, you can do that. Like here you have this rebed and this opening over this circumference welding line, so you would like to indicate that in your 3D PDF. How we can do that and how we can export and deal with the 3D PDF. In this tutorial we will learn, inshallah, how to do that. Here from the 3D model you will open the File tab, and from Export you will select the 3D PDF, and from here you can select the quality. The low quality is enough. You will not need to make it medium or high, so let's keep it low, and from here select the location of the exported file, so you can name it, so we can give it a name like 3D PDF model for this equipment for HEV 000110. Okay, and click on Save. Now from Publish we can start publishing the 3D model. Before this step we can do something important. Let's take this a copy from this and cancel right now, so we can make some views here from the representations. We have the default view. If you double click on it, and you can see here, so we need to remove all the UCS points, and let's make it not a perspective view. Select orthographic view, and let's keep that as a default view. Now let's add another view, like a top view, like that, and adjust the view to be from the top. So that's the top view. Let's add another view like back view. Okay, so that's the back view. Let's add another one as a bottom view. And let's take a look from the bottom. Okay, and make the orientation like that. And another view from the left view. So let's take a look from the left. So that's the left view. Another view from the right view. And now I think we have the all views. Let's add one more one, which is the isometric view. Okay, and make it looks like that. And one for the David. And make this view is closed like that for the David. So now we have some views stored here, some for one of them for default, one for top, back, so, and another one for that. Now when you try to export the 3D PDF file like that, let's change the location and the name of the file and click on Save. And from here let's click on Publish. As you can see here, you have those views that you select, which is default view, top view, and all of the other views. And from here you will click on Publish, and Autodesk Inventor tool, which creating the 3D PDF, will create the 3D PDF file for this equipment. We will wait until exporting the file, and we will know how we deal with the 3D PDF. Okay, now we have the 3D PDF file after creating on SEG software. By using the left button on the mouse and by drag and move, you can rotate the equipment like that. And by the ruler on the mouse, you can zoom in or zoom out like that. And if you click the right button and the left button on the mouse, that will give you the option for banning. Both of them, drag and move, the right and left click, both of them drag and move, so you can ban the 3D model. You can get those options from here: rotate, spin, pan, zoom, all of that you can get it from here. Okay, so here that's the default view, and from here down you can move between the views, like getting the David view. And if it's not appear from here, some graphic cards not give you the ability to select that, so you can select it from this drop down list. So you can select it from that side if that bottom bar not appears, so you can select it from here, the left view or the David view, like that. And you can use some other tools like measurement tool. So if you would like to measure some dimensions, so let's make a band like that, as we discussed, making a band by double clicking on the right and left buttons on the mouse on the same time. So from here you can measure the distance. So if you would like to measure the distance from here to there, it's like that, 310. And you can see you will get a tool here, give you the ability, if you would like to measure a radius or an angle or perpendicular angle. Many options, you can find them here. And if you would like to add a 3D comment, you can add a 3D comment. Like if you have a clash or something like that, you can add a comment here like that, like near area. Okay, something like that. So by that way you can get a 3D comment for your client, so he can figure out what you would like to say, and actually he can measure everything from this view. Okay, so by using this technique you will be able to replace the sheet metal development or the shell development drawing by using the 3D PDF. I hope in this tutorial I give you a good indication about the 3D PDF comparing with the traditional way of getting the clashes by making the shell development drawing. And inshallah we will continue with another part of tutorial to show you how to prepare the fabrication drawings for this equipment. Have a nice day. Assalamu alaikum wa rahmatullahi wa barakatuh.